This video is brought to you by The Ultimate Guide to Rebuilding Civilization or simply the book, but more on it later. Hi guys, welcome to Amateur Chemistry. So we all know wood, right? These beautiful pieces of dead trees have thousands of applications in almost every corner of our lives, from the chair you're sitting on to the firewood in your chimney. I was honestly always kind of fascinated with how such a basic thing can have so many uses, and after turning it into nitric acid, nice crystals and artificial silk, I have no doubts it's one of the coolest materials there are. Now, making nitric acid from wood is already quite a big feat in of itself, but what I always wanted to do was step it up a notch and turn wood into usable alcohol. This idea is actually not as wild as you might think, and while at first glance wood has really nothing to do with alcohol, on a chemical and historical level it's almost impossible to mention one without the other. You see, humans have been turning wood into alcohol for literally thousands of years, and only in the most recent history has the process become kind of forgotten in light of more modern techniques. The alcohol obtained from wood is known very creatively as wood alcohol or wood spirit, and what's quite surprising, it substantially differs from the drinking alcohol we are used to. That's because on the chemical level, these alcohols are two separate molecules with different names. They are called alcohols because they contain this OH group at their ends, however they differ in how many carbon atoms each one contains. Ethanol, which is the alcohol in things like vodka, contains 2 carbon atoms and doesn't outright kill us when we drink it. Methanol, however, containing just 1 carbon atom can easily blind and kill you, and it conveniently is a prime constituent of wood spirit. Now you may ask why I want to make this rather unpleasant alcohol from wood instead of trying to make some edible wood moonshine, and while I could also look into that if enough people are interested, turning wood into methanol is honestly much easier and just as interesting. That's because methanol, much like wood, has hundreds of uses, especially in chemistry, as the most basic of reagents and a versatile solvent, as well as a prime example of renewable ecological fuel. The ability to get such a versatile thing from literal wood really tickles my amateur chemistry soul, especially when paired with the process being kind of forgotten and sparsely covered here on YouTube. This whole project also has a nice DIY and survival feel to it. I mean, it's the kind of thing you would do when you'd want to rebuild a civilization without access to complicated tools and processes, which perfectly ties in with the sponsor of this video, the book. The book, or more precisely, The Ultimate Guide to Rebuilding Civilization, is not just your average book. It's a beautifully illustrated encyclopedia packed with the most amazing inventions and discoveries that humanity has come up with. It covers 180 topics across 23 chapters, from ancient engineering and early chemistry to agriculture, navigation, and even printing presses, all explained in a way that's accessible, clever, and incredibly fun. It's a 2023 bestseller that raised over $3 million on Kickstarter and Indiegogo and was created by a global team of experienced artists, scientists, and designers. The artwork alone is stunning, consisting of handmade illustrations that blend engineering precision with a medieval aesthetic, printed on high-quality art paper with a beautifully bound cover. Whether you're into survival scenarios, history, science, or just love asking what if, this book gives you the practical and philosophical tools to start over from scratch. So if you've ever wondered how to turn wood into methanol, it's literally in the book. Or reinvent an entire civilization, this is the book for you, and it also happens to make a perfect gift. If you want to grab a copy for yourself or a friend, check it out through the QR code on the screen or the link in the description and use my promo code for 10% off on your purchase. Anyway, to make methanol from wood, I basically just have to heat it up, which decomposes it on a chemical level, leaving behind charcoal and a bunch of volatile chemicals collectively known as wood gas. A part of this wood gas is my precious methanol, which I should then be able to recover quite easily. This whole process is really similar to burning, where the wood also gets heated up, releasing a bunch of gas. This gas, however, quickly burns, decomposing any useful chemicals in it and creating heat, which in turn makes the wood produce more gas, repeating the cycle. This means that to get my alcohol, I need to heat the wood without air so that it doesn't burn, which in turn means that I have to construct some evil scientist wood heating apparatus, which adds some more challenge to this seemingly easy project. I also wonder what the final methanol yield will be, since this could potentially turn out to be a viable methanol source in places where it's hard to get. Okay, so to start violently disposing of plant corpses for material gain, I first have to figure out what type of wood I want to use. You see, from what I read when researching for this project, different kinds of wood can give very different results when it comes to methanol production. In general, it's best to avoid woods with a lot of resin in them, such as pine, and it seems that most methanol can be extracted from hardwoods with a low resin and moisture content. This makes sense since it's the wood fibers that eventually turn into gas, and to find some good wood I fortunately didn't have to look around too much. That's because for some reason I possess this mountain of oak chunks which came from a carpenter who decided that they aren't good enough to make furniture. I, however, find nothing wrong with them and they seem literally perfect for turning into methanol. I picked out a few ones that I liked and put them into a bucket, which I then brought into the lab. In total, I gathered nearly 2.5 kilos of some fine wood, which seems like a little overkill for the scale of this project. However, since I felt weirdly motivated to do this thing right, I decided to work on a 2 kilo scale. To controllably heat my wood in an amateur lab-sized apparatus, aka this paint can, I need to somehow break these chunks up since I can't really use them as they are now. I also wanted to make my final wood have a high surface area so that it has an easier time turning into gas, and after some intense thinking I came up with the perfect solution. You see, I have nothing against abusing this old table saw, which apart from cutting pieces of wood turns out to make some good quality sawdust as well. Just by covering the floor underneath it with cloth, I was able to collect pretty much all the sawdust my cursed wood pulverizing setup generated. After roughly an hour of these unbearably painful sounds, I managed to process all the wood and was honestly quite impressed with how well this thing turned out. I mean, who needs a wood chipper if they can spare a table saw? And with my whole 2 kilos of wood in the form of dust and small chips, I really liked how this project was going. I got all this fluffy wood powder into my bucket, and I theoretically could use it to make the methanol as is. Unfortunately, this would probably take forever, since this sawdust occupies so much volume that I would have to split it into God knows how many portions for each to fit in my can. It is also probably quite wet, which would mean extra water to deal with later, and to make this sawdust meet my strict laboratory standards, I decided to process it a little. First, I got a baking tray and after filling it up with the powdered wood, put it into my lab oven. I baked this forbidden cake at around 160 degrees Celsius for 20 minutes, which should easily get rid of pretty much all the water. After getting the tray out, it indeed seemed that there was no more free moisture present in my sawdust, which was really good, and now to make this thing less fluffy and destroy the residual wood chips, I whipped out my blender. It's honestly really powerful for its size, and after filling it up with as much of the dry sawdust as I could, I turned it on. It had no trouble grinding the wood down to less than half its original volume, and with some defluffed wood powder ready, I repeated this process 10 more times. It's really easy to say it like that, but processing 2 kilos of sawdust using a small oven and a blender is one of the most boring and monotonous tasks I've ever done. After about 4 hours, I was left with this nice container with around 1.5 kilos of dry laboratory-grade wood powder. This whole step really drained the motivation I had earlier and nicely covered my whole lab in wood dust, which for some reason went airborne. On the upside, I could now finally start the fun part of this project, which is heating the hell out of this wood in a paint can. I can't do it in a glass flask like I normally would, since the temperatures required here are quite a bit above what glass can handle. Anyway, to be able to collect the wood gas generated inside the can, I had to modify its lid a little, since if I were to hit my wood dust with it like it is now, it would result in a pretty rad explosion. I decided to fit one of these ground glass joints into the lid of the can, which would make it compatible with all my glassware, and to start I first had to find a spare joint. Unfortunately, it's not like I just have some random glass joints just laying around, and the only option for me to get one is cut it off from some piece of glassware. Since I wasn't really feeling like sacrificing a good flask, I turned to my official glassware graveyard, which by this point contains like $1,000 worth of broken glassware. I picked out this fractionating column which went through a lot, and I would prefer to not go into much detail about it. What's more important than my horrible glassblowing skills are its perfectly intact joints, and to cut out the one I want, I had only one option, which was whipping out my trusty angle grinder. Now, there are videos that outright state that cutting glass with an angle grinder is a bad idea.
Very short answer, no.
However, this is amateur chemistry, and it actually worked much better than I expected. With this perfectly crafted piece of glass ready, I now had to install it in the paint can lid. For that, I drilled out a hole in the lid, and then using the chemist's best friend, aka Teflon tape, tightly joined both pieces together. I didn't know how the tape would react to high temperatures, but I decided not to care, and with this magnificent creation ready, I could fill it up with my powdered wood. I figured that 250 grams of the powder is a perfect amount to fit in the can, which means that to process it all I will have to do 6 runs, and compared to the drying and grinding steps, this honestly didn't seem that bad. Anyway, I compacted the powder in the can by lightly tapping it against my desk, then I installed the modified lid with the help of a hammer. With a little more tinkering, this whole wood heating setup was complete, and apart from the paint can, it also has a water-cooled condenser to trap the methanol, a receiving flask, and this incredibly old and powerful gas stove as the heat source. I have to use it since no puny electric stoves can reach the roughly 400 degrees Celsius required for complete wood decomposition, and it also looks really cool. To start this whole thing up, I turned on the stove and for now set it to low heat. At first nothing seemed to happen, but as the can warmed up, it didn't take long for the wood to start decomposing. This was signaled by some white smoke coming from the can, and while some of it definitely was wood gas, it was probably mostly some residual water vapor. This was actually really good, since if all the air inside the apparatus was displaced, the wood gas wouldn't be able to explode, which is quite nice if you ask me. As I continued heating the can, more and more of these white fumes started making their way through the apparatus, which, apart from making it look weird, really put my fume hood to the test. These fumes are probably some initial wood gas with a high amount of moisture and most of the methanol vapor stripped off by the condenser. Speaking of methanol, along with the hundreds of other condensed compounds of wood gas, it makes its way over to the receiving flask, ending up as this yellow liquid. In terms of the exact chemical reactions going on here, nobody fully understands them, partially because they are incredibly complex. You see, dry wood is mostly composed of cellulose, which is this bulky molecule consisting of hundreds of glucose units bound together in long chains, as well as lignin, which doesn't really have a defined structure and is just a chemical mess manufactured by the tree to support itself. These two main wood components, along with hundreds of other less important things, decompose under the severe heat provided by my gas stove. This decomposition occurs in several stages, the first of which mainly produces water, and methanol is one of the last of its products produced most rapidly at around 400 degrees Celsius. Apart from methanol and water, decomposing wood produces a myriad of different compounds, ranging from pure carbon, which stays behind in the can becoming charcoal, a copious amount of tar, liquids like acetone which condense along with the methanol, as well as gases such as carbon dioxide, nitrogen, methane, and most notably carbon monoxide. Carbon monoxide constitutes the majority of purified wood gas, and it's what makes it quite flammable and able to be used as fuel. It also makes the gas incredibly toxic and deadly as hell, which is why I am doing all this in a very good fume hood. As you can see, this whole thing is basically turning a bunch of solid random chemical junk into more random chemical junk, but in all three states of matter, which contains a small fraction of my target methanol. To make it easier for my stove to heat the can evenly, I covered it in some aluminum foil and cranked up the heat, which, apart from flooding my fume hood with even more white fog, made the stove heat up so much I had to cover a part of it with a wet towel to keep it from melting. As time went on, the gas coming from the can contained more of this black tar, which coated the walls of most of my glassware, and just from the looks of it will be an absolute pain to clean. Its formation also signaled that it was getting really toasty inside the can, and this should be the stage where most methanol gets created. Indeed, it seemed that there was a second layer of liquid collecting in the receiving flask, and I was really happy to see just how much of it came from only 250 grams of wood. Anyway, at some point the distillation really slowed down and there seemed to be no more wood gas coming over, which probably meant that all the wood had completely decomposed. It's really quite nice when your distillation stops on its own, and now to take a closer look at my product, I collected the receiving flask. As you can see, the liquid inside it was this goopy mess of probably over 100 compounds. It also smelled really weird, kind of resembling artificial smoke flavoring, which I guess kind of makes sense. Along with the main product, this distillation also left me with a good amount of some fine powdered charcoal, which I might use for something in the future. The distillation also nicely coated the inside of the can as well as the condenser in this thick oak tar, which, as I expected, took me like an hour to clean. Anyway, to continue the project, I have to process the rest of my wood powder, and I wasn't really looking forward to repeating this funky distillation 5 more times, but I figured it's time to train my patience and again assembled the apparatus. I modified it a little to fix a few issues the first one faced. Most notably, I insulated the can and the stove from the beginning and added a longer condenser to hopefully ensure even better methanol capture. I also set up this little goober here, which is a wash bottle connected to the gas output of the apparatus. It's filled with some water and will clean the gas of most dust and tar, hopefully making it suitable to be burned above this little metal pipe near the condenser. To test out my new wood gas system, I cranked up the stove and waited for the wood to start decomposing. After only like 2 minutes, some white smoke started coming over and a bunch of liquid started condensing in the receiver exactly like before. The water in the wash bottle quickly started looking like apple juice from the tar in the gas passing through it, and even after getting washed with water, it still looked foggy. Nonetheless, I wanted to see if it burns, and after bringing a blowtorch close to the gas stream, it quickly ignited, forming this cool flame. I was really surprised by how brightly and cleanly it burned, and this turned out to be an amazing way of disposing of the copious amount of carbon monoxide generated by the process. This flame could also in theory be used for heating the wood, and I wonder if it could sustain itself like a real fire. Anyway, this distillation went pretty much exactly like the first one, with quite a bit of liquid making its way into the receiving flask. Since I had 4 more to carry out, I didn't bother to disassemble the apparatus and did them all in one go. This took a whole day, but other than that went rather smoothly, in the end leaving me with these 2 nearly full flasks of some smoky wood juice along with a bowl full of charcoal powder that constantly kept igniting for some reason. The amount of distillate I got from just 2 kilos of wood was honestly quite astonishing, since I expected to get maybe half of that, and now with all the distillations finished, I can start recovering my wood alcohol. There are probably only a few % of it in the distillate, along with a ton of random junk, and separating it is honestly quite tricky. You see, apart from water, which forms the majority of my wood juice, things like acetic acid and acetone are also mixed with my methanol. To separate them, I have to use some special techniques, and I decided to first separate out the acetic acid. For that, I poured all my tarry distillate into a big beaker, and using a spoon started dropping in small scoops of baking soda. This made the mixture start bubbling quite vigorously, which is the result of the reaction between acetic acid and baking soda. Acetic acid, being an acid, reacts with baking soda, which is a base, in an acid-base reaction to form water, carbon dioxide bubbles, and a salt called sodium acetate. This doesn't separate out the acetic acid in a classical sense, but renders it completely non-volatile, meaning that it won't evaporate when I later heat this solution. This is very good for removing the methanol, and I was honestly kind of surprised by how much baking soda I needed to add before the bubbles stopped being produced. This whole carbon dioxide evolution also caused the dense layer of black tar to rise to the top only to later fall back down, which made for a really exotic lava lamp. Anyway, with all the acetic acid reacted away, it was now time to pull methanol out of this mixture, for which I first poured my smelly wood sludge into a flask. I then assembled it into a very beefy distillation setup, which while similar to the previous one is quite a bit more sophisticated. You see, to separate my methanol from the mixture, I have to selectively boil out and condense it. If I were to boil only methanol without all the other junk, this would be much easier and a simple distillation setup would be more than enough. However, here the methanol is mixed with other liquids with similar boiling points. A major one is acetone, which with a boiling point of 56 degrees Celsius sits dangerously close to methanol's 64.7. This means that if I were to distill this mixture in a normal apparatus, the resulting methanol would be contaminated with a ton of acetone, and I wouldn't really be able to separate the two. Using this chunky piece of glassware called a fractionating column, however, allows me to have a much easier time when separating liquids with similar boiling points. Thanks to these small protrusions, it has a high surface area, which makes the incoming liquid vapors condense and evaporate hundreds of times across the whole column. This results in a much better separation, and using a thermometer I can easily tell what liquid I am collecting. Anyway, after about half an hour of heating the wood distillate, it started to boil quite vigorously and its vapors started quickly traveling up the column. After a few more minutes, I started collecting this weirdly yellow liquid at around 56 degrees Celsius, which had to be acetone. It's probably contaminated with some random, more volatile components of the wood slurry, however, since here I am only after pure methanol, I didn't really care. Fortunately, the mixture turned out to contain only a small amount of acetone, since when there were just a few milliliters of it in the flask, the temperature of the top of the column started rapidly dropping. This meant that I collected the whole acetone fraction, and now methanol, which has the second lowest boiling point of the wood's distillate components, started climbing the column. Before it made its way to the top, I switched the receiving flask for a bigger one, and not long after that, the thermometer displayed a temperature of 65 degrees Celsius, which is pretty much exactly methanol's boiling point. Indeed, quite a bit of some still weirdly yellow methanol started coming over, and I was really impressed by how much of it I ended up with. I mean, compared to the acetone, this yield was just stunning, and I suspect that's because a lot of the acetone could have reacted with something in the mixture in the presence of baking soda. Anyway, when no more liquid was coming over and the temperature started rising again, I turned off the heating and disassembled the apparatus. The main product of this whole endeavor was this half-full flask of dirty methanol, and while I was really proud that in the end I managed to make it, I wanted to make it at least a bit purer than it is now. It probably contains a good bit of water as well as some very stinky organic contaminants, and to remove the latter, I added a spoonful of activated charcoal into the flask. It, having a tremendously large surface area, should absorb most contaminants in my methanol, hopefully getting rid of the nasty smell and color. After leaving it to do its thing overnight, I filtered it off using some cotton, and indeed, the methanol seemed to take on a slightly lighter hue, with most of the horrible cigarette smoke-like smell now gone. To get the last few percent of purity, I got some of these small clay balls into the methanol bottle, which should pull out any traces of moisture. They are professionally called 3A molecular sieves, and they are basically made of some incredibly tiny atomic cages which trap water but leave methanol untouched. You can actually see them work because as they absorb water, they create these tiny air bubbles, And after letting them dry my methanol for about 10 hours, it was time to finally see how much product I have. I got it all into a graduated cylinder, and it turned out that from the whole 2 kilograms of oak, I managed to make 41.6 grams of quite pure methanol. Now, this yield may seem laughable considering the amount of work I put into this project, and it honestly kind of is. However, after doing some research, I found that it's actually quite average. Fortunately, it's way more than enough to do some experiments with, and as the first one, I decided to see how well it burns. For that, I pipetted some of it onto a watch glass and lit it on fire. It honestly burned quite well with an almost invisible flame characteristic of methanol. Compared to some store-bought methanol, I couldn't really see any difference in the size of the flame or burn time, which meant that this methanol is perfectly suited to be used as fuel. For the second experiment, I decided to react my wood methanol with some sodium metal, which is very reactive, and with things like water, it likes to violently explode. Upon dropping it in, it started vigorously bubbling and made the methanol turn brown, which tells me that it doesn't contain much water, but still has a few percent of acetone in it, which reacts with sodium to form this brown tar. Overall, my methanol should be pure enough for most syntheses where residual acetone isn't a problem, and I think that this project was a really nice example of some obscure but doable chemistry with a cool historical background. Now, the usefulness of this method of making methanol over just buying it is rather small, however, it's nice to see that it can be done quite reliably and without any weird chemicals. It's projects like these that nicely showcase the versatility of chemistry, since how cool is that you can turn literal wood into useful alcohol, among other incredibly cool things. If enough people are interested, I could spend some more time developing this whole wood distillation process to, for example, recover the acetic acid. However, for now, I have to sincerely thank you all for watching, since this project just wouldn't be possible without you guys. If you'd like to support what I do, please consider subscribing, liking the video and sharing it with a friend. If you want to directly contribute to improving my videos, as well as having access to a lot of exclusive content like my lab tour, I invite you to become a patron. Speaking of my patrons, they allow me to have the funds necessary to keep taking on unique projects and motivate me to keep making content, and I want to dearly thank each and every one of them for their generous support. Anyway, thanks again for watching and see you all in the next video.